we're going to talk about inverse functions here because they're important. Let me first express to you guys the idea behind an inverse function. Okay? It's actually, it should be called a reverse function, just so you guys know. Inverse functions, reverse functions. Let's note here. Let me put this next to each other here. Here's how this works so that you guys know. Remember this machine, this concept here for f? Yeah, we put in these things, x as an input, f of x as a what? Output. So let's designate these ideas here. We got some inputs, and these are our what? Outputs. And what kind of things did we put in our machine the other day? We put like a beet. We put like an apple. And let's say a pear for now, okay? And if these are our inputs, a beet, an apple, and a pear, what do we get for outputs? Juice. We get beet what? Beet juice, because this is a juicer, right? And then you get what? Apple juice, and then you get pear juice, and these are my outputs. Is that a simple idea? Okay, now I'm going to talk about really something kind of amazing. That what if we had a machine that worked in reverse?
Made it from juice too.
Yes, exactly. Meaning, I'm going to have my machine work in reverse. What I'm going to do is this. My inputs are now going to be, let's say, beet juice. If I put beet juice in my reverse machine, what should I get? I should get a beet. Is that true?
Yeah.
Okay, let's actually change the color since we're... Let's see, what does reverse kind of feel like? Maybe green? Maybe. Let's see. If I plug in beet juice in my reverse machine, I should get a beet. If I plug in apple juice in my reverse machine, what should I get? An apple. If I plug in pear juice, what should I get? A pear. Now, this machine is supposed to work in what we call reverse, right? So the notation we use here is actually, it looks like this. Be careful, this is, I know it's a -1 power. That doesn't mean reciprocal, but the reverse notation here, if you ever see this F with that symbol, they're really talking about the reverse function. Now, it's really not known as the reverse. I call it the reverse because it works in reverse. It's really formally known as the inverse function. It does what's called the inverse. That's saying the same kind of thing. Okay, this is an inverse function. And a trait for this is simply that we switch inputs and what? Outputs. Okay? And we're going to see later is that we actually switch our x and y values. That's what this means when we say inputs and outputs. So here's my general description for you guys of an inverse function. It should really be called a reverse function, but that's when my domain and range switch, I should say, or the inputs and outputs switch. And the notation we have here is inverse functions. So let me give you an example of what I'm talking about, of what we say inverse functions. I can say here's a function that you have as 2x plus 3. And here's another function, and I'm going to use this notation here. Let's see if I can figure this out. Okay. X minus 3 over 2. Okay, I just want to let you guys know. Let me put it a little closer. X minus 3 over 2. Write it a little better. Now let's check some inputs and generate some outputs, right? So let's say we're going to use as inputs. Let's look at our inputs here to be, well, let's do the first one. Let's let it be -1, and then maybe 0, and then maybe 2. And this is my inputs for the function f, and I'm going to get my outputs here. And so f of -1 is an output, f of 0 is an output, f of 2 is an output. Okay, so let's find the value of -1. You guys did your homework, right? Plug in -1 for x, and don't you get +1? Okay. Let's find the output here when the input is 0. That's 2 times 0 plus 3. What do you get? That's 3. Good. Okay. And then we have f of 2 being 2 times 2 plus 3, which is 4 plus 3. And you're right, that equals what? 7. So these are all, again, output values. Is that right? Or I should say apple juice, beet juice, pear juice. Okay, let's kind of write that down next to it. Apple juice, beet juice. And then you say I have some pear juice. Now this is my function f. Okay, so all of these inputs gave me these associated outputs. And I can summarize them in terms of coordinates. I can say when x is -1, y is +1. When x is 0, y is 3. Right? When x is 2, y is 7. Now, these are the x values and y values. Now, what does a reverse machine actually do again? It does what? We're going to switch the x and y values. In other words, my reverse machine should have things that look like this, right? The ordered pair should be now 1, -1, 3, 0, and 7, 2. So you guys don't know this yet, but you will. You'll know this. X minus 3 over 2 is a special reverse function, or the inverse function, I should say. Okay? I know it's an inverse because it has this special notation. Okay? This means inverse function. So let's check it. So how can we check it? Yes, plug in the values. In other words, I'm going to plug in 1 here for x. You say, why am I going to plug in 1 here? I'm going to plug in this output. See if it works in reverse. So when I plug in 1, what do I get? I should get what? F a -1 is 1 minus 3 over 2, or -2 over 2, which is, what does this equal? Is that -1? So what we're saying is, when my input is 1, my output is -1. Isn't that what we said we should get?
Yes.
Notice this. Didn't we say that? We said, oh, look. Here is my apple. So what I plugged in, the reverse machine, is I plugged in my apple juice, and I got my what? My apple right here. Okay? Here's the apple juice, and here's my what? Here's my apple. Did the ordered pair switch? Is it now 1, -1?
Yes.
Right? You see these values go back over here in red. 1, -1 is what we got here. They switched from the original -1, 1. Those two switched. Okay, so it's working how? In reverse. Okay, you okay with that? It's working in reverse? Okay, now let's plug in our machine just so you guys can see. Here's my inverse machine. It's x minus 3 over 2. Let's now plug in, what's the second value? Plug in let's plug in this value. Like we said, here's our beet juice. Plug in 3, we should get 0. So if I plug in 3, sure enough, don't I have what? what does this give me now if I plug in 3? Don't I get f of 3 being 3 minus 3 over 2, or 0 over 2, which is what? 0. It's working in reverse. Okay. Now, what's the last one? Just to double check. Let's let my input now be what? 7. It should give me an output of 2. If it's truly working in reverse. So let's see if the input of 7 now gives me a 2. Let's see, a 7 and a 7. So we're going to end up with, let's change it. F inverse of 7 is 7 minus 3 over 2. What's 7 minus 3? 4 divided by 2. Does that give you a 2? Sure enough, this is working how? This is working in reverse, isn't it? Okay? So that's working in reverse. Now, what I'm going to say to you guys is this. We're going to actually study inverse functions in a lot more detail because they're important. They work in reverse or inverse. Okay? All right, let's see. Which functions have inverses? Remember, we were talking about inverses the other day, and we were talking about how inverses really are reverse functions, all this work we did. Okay, we're coming back to it. So which functions have inverses? And the answer to that question is functions that are 1-to-1. Okay, 1-to-1, meaning they have a 1-to-1 correspondence. And to give you a definition of 1-to-1, there is a definition. And there's a definition, there's how it feels. I'm going to say a function f is 1-to-1 when you have the following. Let's say this. I'll do it this way for you guys. F of A equals f of B implies that A is the same as B. Now, let me give you this in detail. Remember what this is saying is this. F of A and F of B, what is that? These are equal what? Outputs. Imply or guarantee that you had equal inputs. Because remember, f of A, remember what f of A is? Let's see, let's find the inputs. A and B are inputs. So you have f of A and f of B, those are outputs. And we're saying the outputs are here. The outputs are equal. Implies, guarantees that you had equal input. So here's kind of what this looks like for us. Let's give you some examples here. For example, question number 1, they give you a function here that's 2x minus 3. So let me go with this definition for you, show you how it works for a couple of these, and then we're going to move on, and I'll show you how to really kind of do it. But here's what we're going to do. This formally, if this were a higher order math course, not intermediate algebra, maybe a pre-calculus or calculus class, they talk about one-to-one functions. You talk about them in a trig course. Here's how it works, right? You're going to assume here that, right, that f of A equals f of B. And in this case, we replace x with the input A, and you get 2a minus 3. Then replace the input B here, or x with B, equals 2b minus 3. So notice what I did. A is an input, and I get 2a minus 3 as the output. B is an input, and I get 2b minus 3 as an output. you're looking at it right here. We set them equal to each other. So we set those equations equal to each other. And then I'm going to say to people, can you show that A is really the value B? And the answer is yes, we can. We can guarantee that. So we can guarantee that A is B from this setup because we can add now 3 to both sides to this equation. We get 2A is 2B. We can divide both sides by 2. And sure enough, what do we know? A is B. Now, this is what this means. When we assumed here that the outputs were equal outputs, we showed, or we guaranteed, that the inputs are the same. Okay? Meaning equal outputs guarantee equal inputs. And what you guys are kind of looking at here is really a proof that you can see like in a more advanced math course. You know, and it's not like it's not more advanced for you. You can do this still, but you know, in an intermediate algebra course, we're gonna talk about something else. But this is how you formally look at it. But I always show the definition and what it means because it's important. Now I'm gonna say what you're gonna say in this question here for number 1 is they're gonna say determine whether this function is 1-to-1, and the answer for you guys is yes. This is a 1-to-1 what? Function. Now, I'm going to say to you, by the way, so here's a note. Here's a 1-to-1 function. What kind of function is this? So let's note. This is a linear what? Function. It's a linear function. And linear functions we're going to see are generally 1-to-1 functions. Linear functions are 1-to-1. I'm going to see why. Okay? Let me give you guys another note. Here's an important note here. Let's look at this function here. That's quadratic. You guys remember this function? Okay. This function, the question is going to be, is this 1-to-1? Is it a 1-to-1 function? Well, here's what you guys do again. You assume f of A equals f of B to guarantee or to show that we have the same inputs, that A is B. Now I go through the same process. You go, okay, let my input be A, let my input be B, and what I end up getting is to say that f of A is the same as f of B. Well, that means when my input is A, my output is A squared. When my input is B, my output is B squared. So we're saying when A squared equals B squared, can we guarantee that A equals B? If we can, then we can say the function is 1-to-1. If we can't, then it's not 1-to-1. So let's use some algebra. So you say, okay, how do you use algebra? Well, I can solve this quadratic, right? Subtract B squared from both sides here. And then you end up getting A plus B times A minus B equals 0, just by factoring, okay? And then, by the 0 product rule, A plus B is 0, A minus B is 0, subtract your B, A is minus B, add your B, A is B. Now, let me show you what this means. Can I guarantee for this quadratic function that equal outputs give me equal inputs? The answer is a big what? Yes or no? Good. How do you guys know it's a no? Because A certainly can be B, or it can be what? Opposite B. It can be B, or it could be opposite B. So this is a no. So this function is simply known as it's not 1-to-1. All right, let's look at some details now. Okay, this is what you see in a more formal sort of setting. You can prove it. You can kind of do it in an algebra course. That's not too bad. We didn't use anything other than algebra. But you don't have to necessarily do this. This is where you're headed. Here's what I want to say to you guys. Remember I said linear functions are one-to-one? We looked at the function 2x minus 3. Let's compare that function to the one we just looked at, x squared. Let's look at the graphs. Now, here's what you guys can do. If you graph this function, we go at -3 here. Our slope is 2. So it goes up 1 here. This is my line. My y-intercept's at -3. I kind of crudely graph this. I'm going to crudely graph x squared. It's a parabola. Vertex is at my origin. We graph parabolas. You guys know all about them. So I have my x-axis, I have my y-axis. Does everybody agree that these are kind of the graphs? Here's how this works here. You guys are going to use what we call the vertical line test. What does vertical mean? Is it up and down or left and... Sorry, I messed up. Sorry. I mentioned I had no sleep. The horizontal line test. What does horizontal look like? Left to right. Okay. Horizontal line. Horizontal line. All right, you guys okay with that? You're going to use horizontal line test. This is a legitimate thing. If you touch this curve at exactly 1 point everywhere, it has to be 1 point. Only 1 point. Then you could say the function's 1-to-1. See, here's another horizontal line. Do you hit that curve in only 1 point? Okay. In fact, anywhere you draw this horizontal line, you're going to hit this curve at exactly 1 point. And what this means is that my function is 1-to-1. And that's where they're getting at. If you hit the curve at more than 1 point, like over here, here, there, and there, guess what that is? It's not 1-to-1. So you have to hit your curve at exactly one spot only. So this is not 1-to-1. So there's a very simple way you can do this, and that's simply by graphing. Okay, now notice some details. If x is 1 or x is -1, remember we said this function's not 1-to-1, this quadratic? Notice this. For the quadratic function, could you tell me what f of 1 is? Isn't that 1 squared, which is 1? And f of -1 is -1 squared, which is +1? So here's what I'm saying to you, that even though you have equal outputs, in other words, f of -1 does equal f of 1 because they're both 1. What do you guys know about the inputs? -1 is not the same as +1. So equal outputs, non-equal what? Inputs. This is why this is called a counterexample. This is why this function of x squared is really not 1-to-1. This is a quadratic. Sorry, I'm trying to get the highlight. My quadratic function, x squared, is not 1-to-1. And there's various reasons. We proved it. We looked at a counterexample. We've seen that the horizontal line test touches this curve at exactly one spot and not 1-to-1. So the key is to draw a curve, okay? That's what we're going to go with. So we could have drawn a curve here, 2x minus 3 right here. Use a horizontal line test, we know it's 1-to-1. And that was number 1. Now go to number 3. Number 3, we're going to say this to you guys. You get x plus 3 squared. This here, if we draw this curve, what kind of curve do you think it is? parabola. How do you know? Because this what? Didn't you guys have a test on some of these parabolas? Highest power is 2. Didn't you graph that? Your vertex is at negative 3, 0. What do you guys know about this? Draw your horizontal line test. What's the issue? 2 points of intersection. What do we say? Not 1 to 1. Okay, it's not 1 to 1. Number 5. Didn't we see this number before? Square root of x plus 1. What does that curve look like? Yeah, this is square root function. Starting at negative 1, let's see if we draw this horizontal line. Will you hit this curve in only one spot? Yes. This is, what do we say? 1 to 1. Good. One nice 1 to 1 function. So you want to know what kind of curve you get. Number 7. I'm going to tell you what kind of curve this is. Okay? Let's give you information on this curve. Let's note. This curve, you guys know what it looks like? Let me show you. This curve looks like this. Okay? Now, what do you know about this particular curve? If I draw my horizontal line, this curve is 1 to 1. Is that true? Okay. Do you know what this curve in black looks like? It looks like the curve x cubed, but it's going to be shifted down 2 units. So I shift everything down 2 units, and this point now is now over here. Is this 1 to 1? Well, how do we know? Do you hit the curve in only one spot? Yes. Yes. So this curve also is 1 to 1. So essentially, if you know something about the x curve, like over here, if you know something about the radical, you can say whether it's 1 to 1 or not. Okay? You guys okay with that? So know these particular curves so you can answer 1 to 1 questions. We said 7 is 1 to 1. Now let's see, what does that leave us? Number 9. Oh, number 9. Let me say this. Here's my function for number 9. Let's see if we can figure out this function. This is the absolute value. Let's note. Do you guys know how the absolute value curve looks? Let me show you. The absolute value looks like this. Okay, this is the absolute value curve. It's a V. All right, now let's double check. Is this, it's not horizontal, but is this 1 to 1? What's the problem? 2 points of intersection, not 1 to 1. What do you think it's going to mean about number 9 up here? It's not what? 1 to 1. You almost spelled it backwards. Okay, because really this curve here, x plus 3, the vertex is at negative 3, 0. So the left 3 here, just so you guys know. Similarly, so the point I'm making is if you know something about this curve, the absolute value curve, you can say something about the absolute value of x plus 3. Okay, so these are some curves you want to have in the back of your mind. The absolute value, this x to the 3rd power, square root. You know, we can say, what would I think of here? Didn't we draw this last time? Remember this one? Square root curve. Right, you miss one day, you miss a lot. Wasn't that a square root curve last time? It was, and notice again, 1 to 1. Is that right? Hits that in one spot. So in my mind, I go back to these curves that I remember. All of these here. That curve, even, I think I wrote it somewhere, this nice right here, x squared, not 1 to 1. Not 1 to 1. I know the square root curve, this x to the third power curve, my absolute value curve. If I know those curves, I can answer 1 to 1 questions. Yes?
So the parabola and the absolute value, those are always not going to be?
Yep.
Because it's always going to be points.
That's right. It fails the horizontal line test. I almost said it again, vertical. Horizontal line test is your Math 125 tool. Right? Horizontal line test. Now, let me show you a couple of other curves, by the way. And when you move on to those more advanced math classes, like at 260 or something, they're going to come back to these curves and ask you those, hey, are they 1 to 1? And, you know, I think, and they want to know domain questions. We talked about those. Let me introduce you to this. The graph here. Oh, it's a hyperbola. Let's see what happened to our. Okay, let me draw my x-axis, my y-axis here. Sorry, my sketches are the way they are. Here's it's called a hyperbola, by the way. Okay. Let me draw it a little more correct. Yeah. Here we go again. Okay, x-axis, y-axis. You know what's interesting about this curve? There's a lot of things. First thing I want to point out to you, it has what's called, it never crosses the x-axis, never crosses the y-axis. It has what's called vertical and horizontal asymptotes. Now, more importantly, is it 1 to 1? What do you guys think? What does a horizontal line test tell me? I hit at only what? 1 point. Now, that means my hyperbola is 1 to 1. Now, what's going on with this curve up here? It's a hyperbola, but it's shifted 4 units to the right. So there is an issue here about shifting. I'll point down here. If you know what 1 over x looks like, then you can actually start to sketch 1 over x minus 4. It shifted 4 units. More importantly, we could just simply summarize it and say it is 1 to 1 because of the fact that we know already that any function that looks like this in this family is going to be 1 to 1. So if you know the family, then you know what's going on. And then the last one, I should say, that we should look at, that's 1 to 1. Number 13. Okay.
Number 7, what'd you call number 7?
7? Well, it doesn't have a name, but it's x to the third power.
Okay.
It kind of looks like a snake. Is that right? A snake. In fact, I'll show you what one of my most famous math students ever, said about this curve here. Okay, you guys know who one of my most famous math students is? Besides all of you, is that a lie? You're not famous?
I am.
You're famous?
That really is.
Yes. He's not so young anymore.
Works for NASA? What do you work for?
Yeah, he works for NASA, or he's actually going to graduate school in Arizona. The last he sent me. And the reason I bring him up is because every time, gosh, it's so late in the day and can't even sketch a curve on an iPad that's falling off the table. God, look at that. Horrible. All right. x-axis, y-axis. Again, we have these asymptotes. Okay, both vertical and horizontal. We never cross these lines. Okay. Is this function 1 to 1? No. How do you know it's not 1 to 1?
Because they have 2 points.
Right, it crosses your curve where? At what? At 2 points, really. All right, you guys see that? It fails a horizontal line test. So this is not 1 to 1. Which means this curve is not 1 to 1. It's the same curve, but it's shifted 3 units to the left. Here's my point. What's the name of this curve? Why did I bring up Moshe? Because every time I drew this curve in a calculus course, and we talked about these kind of curves, he asked that same question. What do we call this one? Like you call the prior one, you called what is that? Hyperbola. What is the name of this? It doesn't have a name. So he said it was a volcano. It looked like a volcano. All right. Does it look like a volcano?
Yeah.
Yeah. Where do you put the virgin? Is that right?
Oh my god.
Hey, that's a male, not a female, so don't think that.
Oh my god, no.
That's why you call it the volcano.
Wow.
Horrible.
Wow.
I know. Skip. Let's not print this. Let's not publish this.
Wow.
Huh? I'm not recording.
Yeah.
Not recording.
That's
I'm gonna bleep that out, like in the interviews. We'll bleep all that out. But anyway, this is how you answer some of these fundamental 1-to-1 questions. Okay. Now let me ask you this: what's the premise? Why do we care? Remember why we care? Which functions have inverses? The answer again is, let's say it again, 1-to-1 what? 1-to-1 functions. So now that you know what it means for a function to be 1-to-1, let me show you here now what they're going to ask you. Here's a function here that is 3x minus 4. Notice this is a linear function. What do you guys know about linear functions? They are 1 to what? 1. Linear functions are 1-to-1. What's so special about them? They have inverses. Okay? Inverses. Now, so I'm going to say this. F has an inverse function. Now we're going to ask you guys this question here. What is the inverse function? What is that inverse function? Well, that we're going to find. Now, this is what you guys are going to focus on. To find an inverse, you're going to follow these 4 steps. You guys ready? Here's your first step. Let y equal f of x. That's step 1. Now you might say, well, what do you mean? Well, see this? That's what we let y be. So you get y equals 3x minus 4. That's what you do for every one of these functions that you have to find the inverse for. Let y be f of x. That's step 1. Step 2. Step 2 is probably the most important step. You're going to switch x and y. Switch those 2 values. Remember, how does an inverse function work? Your domain, your inputs, set of all inputs, become your range, and your range becomes your domain. You're switching these x and y values. X and y values are switching. So what that looks like here is that now x equals 3y minus 4. So here's my steps. Step number 3. Let's do step 3. Solve for y. You say, what do you mean solve for y? I got x equals 3y minus 4. You guys can solve this for y, right? Add 4 to both sides. X plus 4 is 3y. Divide by 3 for both sides, and I get y equals x plus 4 over what? Over 3. That's step 3. Step 4. Let y be f inverse of x. So you are done once you get to this step. You say, what do you mean you're done? You see this y value over here? You see this y that they're talking about? That's the same y. What do you let y be? In other words, this here is your inverse function. It is x plus 4 divided by 3. You have found the inverse. So when your original function is this, f, right here. Here's my original function f. It's 1 to 1. Once you know it's 1 to 1, it has an inverse. Here's my inverse function. It's x plus 4 over 3. And yes, in higher math courses, do we use inverse functions? Absolutely. We use it all the time. Okay. Let's find some inverse functions. First step, you gotta wake up. Step 1. You guys want to tell me what the first step is? You got it in your notes. Y equals 2x plus 5. Step 1. Step 2. What do you guys do? Switch x and y. You guys okay with that? Step 2? Okay. So far, so good? Step 3. Solve x equals 2y plus 5 for y. Subtract 5. X minus 5 is 2y. Divide both sides by 2. And y is x minus 5 over 2. Final answer. Step 4. What's my final answer? F inverse of x is x minus 5 over 2. All right. That's your inverse function. You just have to follow these 4 steps for every one-to-one function. What do you guys think? Easy. Let's do some more. Question?
Can we get the last
You want to write that down? Take a look. Write it down. Write it down. All right, here we go. Let's see if you're awake. Tell me your steps. Step 1, what do you guys do? Let y be f of x. Bless you. Is that step number 1? Okay. I'm going to put this in red. Step 2, an important step. Switch x and y. What does that mean? X is square root of y. So far, so good? Okay. Step 3. Solve for what? y. We got the equation x is the square root of y. Do you guys know how to solve this for y? Good. What do you do? Square both sides. Outstanding. What do you get? X squared is, what's the square root of y to the second power? Good. Good job. That's why. I told you these are easy. And what's the last step? Step what? What's step 4? The inverse is what? X squared. Now, let me make an observation, but before I do that, does anybody have any questions on how I got this inverse? How did we get this inverse? With these 4 steps. You follow this process, right? I want to make an observation here. Everybody okay with that? All right, under this radical, let me point something out to you. What's under this radical? Isn't that x under this radical? Is that true? Okay. Now, what do you know about this x? X, the domain, is greater than or equal to what? To 0. Is that true? You guys okay with that? Isn't under the radical you have to be greater than or equal to 0? Say yes, that was our domain. Okay. Now what happened in step number 2? You switched. What does that mean? It's no longer x now that's greater than or equal to 0. It is y that's greater than or equal to 0. Is that true? What's going on? You guys okay with that? So far so good, right? Okay, y is greater than or equal to 0 because we switched x and y. Go back now over here. Since y is greater than or equal to 0, is this a y here? Is that greater than or equal to 0? So in other words, what? That's the same y. You're dealing with a portion of the parabola. Here, that's what? I want you guys to think about this. You found the inverse function. Okay. This is positive. And over here, we know this is positive. Okay. What do you think this actually means over here for my x value? X has to be what? Positive as well. Now, that's going to come up in our future. I'm going to point out to you guys something interesting about this in our future. Okay, so we're only dealing with one part of our parabola, the positive part. And that will come up. It's number 19. Let's look at 21. I see what you guys say. 17, 19. 17, 19. Oh, okay. There we go. 21 really is. Yeah, we'll fix that typo there. So we'll fix it. It's 21 for us. Go through our steps. Let's find the inverse. Step 1. What do you guys let step 1 be? Y equals square root of x minus 4. What's your second step? Switch x and y. X equals. Okay. What's the third step? Solve for your y value. Okay. It's going to come down to your solving skills. You guys want to tell me, how do you solve this for y? How do you get y by itself? Square, good. Square both sides. Okay. On the left, what do you have? X squared equals. What happens when you square the radical? Good, you get y minus 4. Good, now you add 4. See what you get. X squared plus 4 is y, or y is x squared plus 4. What's the last step? It's your answer step. You're done in step 4. So what do you say? F inverse is, what is it? X squared plus 4. Remember we said, let y be what now? This is your answer. You are done. It's the same what? The same 4 steps over and over again. Okay, notice that the inverse of a square root is a square. 23. F of x is x squared 4. X squared equal to 0. Let's see if you guys can tell me why that is. Why do they define this parabola to be good only for positive values of x? Anybody know anything about this? What does this curve look like again? Change the color. See what we're looking at. What kind of functions have inverses? 1-to-1 functions. Good. Is this parabola 1-to-1? Is parabolas 1-to-1? Generally, no. But let's see what they gave us. They gave us a parabola. X and y. You okay with that? Isn't this my curve? F of x is x squared. And then what do they tell us? They want this to be good only for what values of x? Greater than or equal to 0. Where are those? You're over here. They're to the right. Good. All of these values of x here are positive. They're not, this parabola is not defined for negative values, only positive values. So what that means is you get to remove what? The negative values of x that have no, it's not defined for negative values. So what you have only here is this shape here. It's a half a parabola because they said to you, define this only for x greater than or equal to 0. Bless you. So you might say, why did they do that? Because you now have a very nice what? 1-to-1 function. What this is known as, they restricted the domain. Meaning they restricted your domain so that this curve is 1-to-1. And why should it be 1-to-1? Because you're looking for its inverse. Step 1. Let y be f of x. Y is x squared in it. Now, step 2. What's step 2? Switch x and y. Okay. Step 3. Solve for what? For y. How do we solve this thing for y? Good. Square root what? Y is plus or minus square root of x. Didn't you guys solve these kind of things? Square root formula. This is, I'll put it in red. Square root formula. Okay, now let's go back. Let's see what this means. This means y equals positive square root of x, or y is the negative square root of x, because this is plus or minus by the square root formula. Let's see if you guys can tell me which one is it. Is it positive or is it negative? Let's go back. What did they say over here again? They want x to be greater than or equal to what? 0. Set it right here. I'll put it in purple. If x is greater than or equal to 0, and over here, what did we do? We switched x and y. If x is greater than or equal to 0, then what do you know about this? Let's write it here. Which one of these has y to be greater than or equal to 0? Which one's positive? First one. Good. Throw out this next one. Point being, step number what? 4. We get to give our answer now. The inverse function is square root of x. You're going to let that y be replaced with your inverse function notation. So what you guys are doing is you're finding inverse functions by using this formula, this format, for functions that are 1 to 1. And so that leaves us up to what number now? 23. So I guess we're now at, let's take a look at 25. See what this function is. What did we just get through? Okay. X squared. Okay. 25. X squared minus 2. Okay. Now they're going to say here, again, x is greater than or equal to 0. So this is a nice 1 to 1 function. Okay. Let's find the inverse. Step 1, you let y be x squared minus 2. Step 2, switch your x and your y values. Double check. Anybody have any questions? Isn't that what we've been doing on that second step? Okay, step 3. Solve for the y. Now, what do you have? How do we solve this for y? Add 2. I get x plus 2 is y squared. Okay, I added 2 to both sides. Now what do we do? Y will be plus or minus square root x plus 2. So I get two things. Positive square root of x plus 2. Negative square root of x plus 2. That's an or. Which one do we throw out? Thank you. Why do you throw out that negative? Go back here. X is positive. What did you do over here? Switched the x and y, which means now y is what? Positive. Is that right? This one's the positive answer. So, step number 4, the last step, is our answer step. Replace y with your inverse. This is how you find inverse functions. Remember how that worked in reverse last time? Look, our apples became apple juice. All right, and let's do 27. Thank you. Wow. Did you ever think you'd be finding reverse machines? Now this is going to be for x going to equal to -4, I guess. Okay. Okay. By the way, we restricted the domain, so this is a nice one-to-one function. So let's follow our procedure. You let y be x plus 4 squared. Step 2. Switch x and y. So if you do, you get x is y plus 4 squared. Step 3. Solve for y. Okay. So if I have to solve for y, I get x is y plus 4 to the second power. you guys know how to solve for y? Not square. Take the square root of what? Of both sides. You get square root of x is, what's the square root of something squared? It's y plus 4. You subtract 4 to both sides. Here's what you get. Y is the square root of x minus what? 4. What's your last step? Inverse function is the square root of x minus 4. And then we go to number what? What's the next? What number is this? 29 is 1 over x. Is this nice and 1 to 1? Okay, let's go through let's find the inverse. Replace y with 1 over x. Is that true? Notice this process is the same. Step 2. Switch x and y. You get x is 1 over y. Step 3. What happens in step 3? Solve for y. So I get x is 1 over y. You guys know how to solve for y? Well, isn't this a proportion? Equal ratios? Cross multiply. What do you get? xy is 1. Divide both sides now. We're solving for y. Divide by x. What do we get? Y equals 1 over x. Step 4. What's step 4? My answer step. The inverse function is 1 over x. Look at that. Isn't that interesting? The function is 1 over x, and its inverse is what? 1 over x. It's the same. It's its own inverse. That's weird. 31. F of x is 1 over x minus 3. A nice 1-to-1 function. We have to find the inverse. Follow your procedure. Step 1. Y is 1 over x minus 3. Step number 2. Switch your x and y. X is y minus 3. Whew. Step 3. Solve for y. Okay. Create again. What do you guys want to create? Create your proportion. So why do you think you want to create this particular proportion? Huh? Do you guys know why? So you can what? Cross multiply. Here's the deal. X times y minus 3 is 1. We're going to have to solve that thing for y. Okay, this one's going to be an interesting question. Okay, you guys okay with this? Did I cross multiply? I did. I got to get y by itself. See this y? I got to solve for y now. Here's what you guys do. Distribute. xy minus 3x is 1. I'm solving for y. Add your 3x to both sides. You get xy equal to 3x plus 1. Can you solve this for y? What do you do now? Good, you divide by x. Look at that. Amazing. Y is 3x plus 1 over x. And then sometimes people write this as y equals 3x over x plus 1 over x. Sometimes people will say 3 plus 1 over x. And so my inverse function can be described as 3 plus 1 over x, or 1 over x plus 3. Notice that's different than what you had for f. That's 1 over x minus 3. So here's my f. Here's my what? It's inverse. You're going to follow your procedure. Probably the hardest part would be for you to solve for what? Solve for y. This makes number 33. Make sure you guys remind me here. Here we go. 33. X cubed. We know this is 1 to 1. Let's find the inverse. Step 1, you're going to let y be x cubed. Step 2. What's step 2? Switch x and y. Step 3. Solve for y. We got x is y cubed. You guys know how to solve this for y? Take the, don't cube both sides, take the cube root of both sides. So you get now, the cube root of x will be y. Final step, your inverse function is cube root of x. I'm going too fast? Okay, let's go back. Oh, I'm so sorry, you guys. Way too fast. Huh? You just wrote 33 down. All right. 33, okay. Too fast. How about if we do one more? We'll call this 35. But don't even try this unless you're an A student, because this one is you ready? Maybe, huh? Should we get, I'm going to give you guys, let's do this one 35. This is only for the A students though.
Okay, so all the rest of the students
Okay.
need to leave?
So, is that a horrible thing to say? Is that right? I'm so sorry. X plus 1.
As long as I get to leave.
No. Here we go. Look at this one. Ladies and gentlemen, this is actually a pretty good one. Scary. Let's see if you guys can handle this one, okay? We'll end the day with
Where's Y?
don't worry about it. Here we go. Don't worry. Step number 1. You guys should have this process memorized by now. Y is x plus 1 over x minus 3. Is that true? You just follow your procedure here over and over again. And then, step 2. Switch x and y. When you do that, x is y plus 1, y minus 3. X over 1. Okay, good. So far, so good? Like I said, probably for most people, the hardest step is just step 3. Right? Step 3, we solve for y. So I really didn't learn how to solve equations until I had to find inverse functions. Because I really had to solve everything, right? So everything that you ever had in this course comes back for solving equations. That's why your final is comprehensive, because you have to remember, people go, oh, is it comprehensive? Yeah, it's not like, some of these other courses you take, right? No comment. Okay. You got to use the information you learned. So what you did on day 1, day 2 applies on the last day even. That's why it's comprehensive. Okay? You guys ready to solve this? Let me give you a hint. Good job. Outstanding. You already know. Cross what? Y. You have equal ratios. You have a proportion. X times y minus 3. What's 1 times anything? Good. So just put y plus 1. Notice I cross multiplied. It's cross multiplication. I know. Remember, we're solving for that y. Not so easy to do. Distribute xy minus 3x. It's y plus 1. I have to always remind myself, what am I solving for? Y. Get y on one side of your equation. Get all your y's together. You know, so you can do what you want. You could say this. I'm going to translate. Oh my God, I'm going to use all my algebra skills. Translate, move terms to the other side. Did you ever see that before?
Yes.
Xy minus 1 is, so move the 3x on the other, 3x plus 1. Is that true?
Wait, what happened to the y?
Let's see. Xy didn't move, so it's on the left. 1 didn't move, it's on the right. Oh, that's not 1. That's y. Thank you. Wow. You guys okay with that? We translated. We're using all our algebra skills. We're not done. We're almost there. What are we solving for again? Y and y. Okay. Well, no. I got y in both terms. What are you going to have to do there? You're going to have to factor out the y. Ah, yeah, look at that one. Oh, man. Isn't that? I told you this is for the A students. Wow, this is one that you don't even see coming. Everything in this problem solving. You didn't even see it coming. You didn't even see it coming. You guys know what I mean? I was like, oh, I factor. I get y by it. Now, ladies and gentlemen, you're there. You can get y by itself easily. Divide both sides by x minus 1. Cancel, cancel. Oh, here we go. Y is 3x plus 1 over x minus 1. You guys solve for y. The inverse function. Hold on. Let's write it right. Boy, you guys know what I do for fun at home? Solve like equations all day long. Isn't that fun? Oh my God. Nerds rule the world.
That's true.
Here we go, ladies and gentlemen. That is your answer. And we are what? Out of here. We're out of here.